Hi, I'm Joshua Bedigol, and this is my first project using an Arduino microcontroller. For this project, I decided to build a lighting controller using a photocell for ambient light intensity detection and a 7-segment LED display to provide a visual status readout without the need for a computer. For this project, I used a Mega 2560. You will also notice I have the Ethernet shield installed. Eventually, I plan to add networking capability for the additional status and control options. The first thing I did was figure out how to hook up a 7-segment LED display. Some simple code maps segments to pins for standard numerical characters. Here you can see the Arduino looping through a countdown cycle. The next step was to hook up a photocell to the analog input, where I was able to convert the input value to an integer between 1 and 9. Here you can see that it is properly detecting changes in light intensity. Using the 3-way bulb on its lowest setting, I managed to get readings between 2 and 5. Changing the light bulb to its maximum setting, I was able to pull it up to a 7. However, I couldn't get it to go any higher. I think this may be due to my use of an old photocell, old breadboard, or possibly a loose connection. I considered bringing it out to the sunlight, but was afraid to move it. Theoretically, this should go all the way up to a 9. So now it's time to make this thing actually do something. Here you can see I've hooked up a couple of LEDs to analog output pins. The goal here is to turn them on when the detected light intensity goes below 2. On my first attempt at this, the LED would flicker as the value approached the threshold. I corrected this by adding a buffer to the logic. As long as the value in the display stays the same for 30 passes through the loop, the LED will react. Otherwise, the program ignores the change and restarts the counter. Here I've made it so that one LED illuminates when the value goes below 2, and they both illuminate if the value is below 1. I intended this to control some accent lighting both in my house and along my front walk. At 2 it would begin to turn on lights inside the house, while outside is still too bright to need lighting. At 1 it would be sufficiently dark enough to begin illuminating the front walkway without needlessly wasting electricity too early. This also has the benefit of turning on the necessary inside lights on a dreary overcast day without triggering the outside lights. So there you have it. Hopefully I've provided some useful information for anyone attempting a similar project. I've posted the code and notes on my website for anyone interested in recreating this project. In future videos, I plan to outline how to get this connected to the internet, how to control it using a simple web page, and how to build a smartphone app to control it. Stay tuned.